All right, so for read 2, you are going to see some past concepts resurface here. So we are going to talk about polynomial functions and their graphs. Okay, and I know that most of you have seen this first concept that we're talking about, but not everybody has seen it. So I am going to re-explain it, okay, but I am going to do some of it a little bit quicker. So when we are doing the end behavior of functions, we are just describing what the ends of the graph are doing. That's what we're going to focus on first. Okay, and then we're going to find the local max and mins on a graph, and you'll have your option to use your graphing calculator or Desmos to do that. So for the end behavior, your textbook has this great blue box, it's blue in the book, that talks about the end behavior of polynomials. And when we're talking about the end behavior, in each one of these cases, you're going to see it says as x goes to negative infinity, as x goes to infinity. So for every single one, the reason why you have a negative infinity and an infinity for x is because you are always going to have a left side and a right side. So if you have infinity, or sometimes you might see it as a positive infinity like this, as x goes to infinity, or you can put the plus, the positive infinity. What that means is x becomes very large in the positive direction. And if it's a negative infinity, okay, the x values are becoming large in the negative direction. Okay, whenever you're dealing with x values, when it's getting very large in the positive direction, that's the right side of the graph. Okay, and then the negative would be the left side of the graph. So we're going to use x goes to negative infinity to represent the left side. And then x goes to positive infinity means the right side. Okay, so for some of you, that is review. Okay, and then for the y values, if y goes to negative infinity, it no longer means left. Do you guys remember what that means? Yep, well, up will be positive, yep. So this one will be up and this one will be down. So the y-axis goes up and down, so that's what these are going to describe. The x-axis goes left and right, okay, so that's what it's going to describe. And then you're going to describe the end behavior. So you did this on your preview worksheet where you were looking at the graph and then you wrote it. You are also going to have to be able to do this without a graph. And in order to do that, you just have to know the degree and you have to know the leading coefficient. So if the leading coefficient is positive, let's look at both of these graphs. Okay, and both of these graphs on the right side, can you see that this is going up on the right and up on the right? Okay, and then for the negative leading coefficient, it's going down on which side? That's still on the right side, okay? So it's always about the right, okay? So if it's an odd degree, okay, if it's an odd degree, they go in opposite directions. Okay, the ends go opposite directions. So if one end is going down, the other end is going up. If one end is going up, the other is going down. Okay, for an even degree, it is going to go in the same direction. And I remember that because odd and opposite both start with O, and then you can think about if something is even and you split it up, everybody gets the same amount. So even is the same, odd is opposite, and if one side goes up, the other side follows. If one side goes down, the other side follows. Okay, so the leading coefficient and the degree, those are the two things that you're going to look for. So if it's positive, it's up on the right. If it is negative, down on the right. Okay, some people like to make them both opposite and say down on the left, but that's not true. So if we look here, we can see they're both going down on that right side. Okay, so we're going to determine the end behavior for the function of p. We have p of x equals negative 2x squared plus 3x plus 5. Okay, and we're going to do this without any sort of graph, just based on our rules. So whenever it says determine the end behavior, you're going to write a function, okay? And then when you are, or not a function, you're going to write a sentence, okay, with mathematical symbols. And I believe in last year's textbook, if you were with me last year, they started with as x goes somewhere, y goes somewhere. This is the same thing. They just say p of x first. Okay, it honestly does not matter to me which one goes first, as long as the left side is with the correct value and the right side is with the correct value. Okay, so all we have to do for these is identify the leading coefficient. Okay, and so if the, I guess I like to call it the LCO, the leading coefficient. Okay, if you see it's a negative 2, that means it falls on the right. So which one of these represents the right side, the first or the second? So p of x as x goes somewhere, as x goes to negative infinity. As x goes to negative infinity, what does that part represent? What part of the graph? Well, you guys know. Right? We just talked about it. As x goes to negative infinity, what does it represent? The left side. Okay, so this is saying what happens as the numbers get very small. So on the left side of the graph, okay, this is saying what happens as the x values get very large, which is the right side of the graph. So if we know that it falls on the right, we are going to plug in negative infinity in our first blank because it is going down on the right side. Okay, to fill in this blank, we just have to ask ourselves, is this an even degree or is it an odd degree? So what's our degree for this? Do you remember how to find the degree? Yep, 2, because it's the highest exponent. Yep, so if it's even, they go in the same direction. So if they go in the same direction, if this is negative infinity, then this also has to be negative infinity. So if the degrees are even, your statement for p of x will be the same, and then for x it will always be those opposites. That's the leading coefficient. Yeah, you're okay. Okay, so p of x is equal to x cubed minus x squared minus x. Okay, and you can always start your statement the same way. So instead of y like we did last year, they're using p of x because the polynomials are called p of x. So you're saying, okay, where is p of x going? Where is the graph going as x approaches negative infinity? Okay, and where is the graph going as x approaches positive infinity? Either way is fine. Yeah, you can just write infinity instead of positive. Okay, so then in order to determine what to fill in, again, we are just going to find the leading coefficient and the degree. Okay, so the leading coefficient, what is the leading coefficient here? It's a 1. So it's going to be positive. Okay, so it has to go up on the right. Okay, our degree is 3, so the degree is odd. Okay, so based on those two things, I want you to try to fill in part B. And then I want you to do part C. Okay, so fill in where P of X is going. Okay, so because it is positive, we should have filled in positive infinity on the right. And then odd means they're opposite, so that one's going to be negative infinity. Okay, did you guys have enough time to try part C as well? Okay, so P of X is going somewhere on the left side, and it is going somewhere on the right side. Okay, and you can start filling this in just like I do. Like we know this is our structure, and then we're just filling in the blanks based on these two characteristics. So if the leading coefficient is negative, okay, that's going to tell you something. Okay, and then if the degree is odd, that tells you something. Okay, so if the leading coefficient is negative, it falls on the right side. So this is the right side, so we should have put a negative here. If it's odd, they're going in opposite directions, so this would be positive. Okay, and you can do that exactly how I did. Like I said, I know some of you have done this before and you're not going to have to write that out every time, okay? But if this is new, writing this out is going to help you memorize those rules, okay? So some of you remember the rules from before, others of us are going to use those to help us, okay? All right, and then if you want to check your answers with the graph to make sure like you did the right up and down, you can do that. All right, and then one of our favorite things coming back around, we get to factor. So today we are going to factor the polynomial to find all of its real zeros. And you guys found some real zeros in your preview packet. Do you guys remember where those were? All the real zeros? Yep, where the graph touches the x-axis. So they are the x-intercepts. So factor the polynomial to find all its real zeros. Okay, and the real zeros can always be found on the graph. As you guys were working on this, somebody asked me, oh, are the real zeros going to be the same as the degree? And sometimes it will, but if you have imaginary, it won't be. Okay, and then these are your x-intercepts of the graph. Okay, and then eventually we will move in to finding the imaginary zeros. That will be next week's entertainment. Okay, but this week we're going to be finding the real zeros, and we're going to do that by factoring. Okay, so notice in example 2, it says factor the polynomial and use that factored form to find the zeros. So they're actually telling you to do two things here. So we are going to write the polynomial in factored form here, and we're going to use that factored form to find the zeros. Okay, so 2 tasks, 2 answers. We got this. Okay, so for part A, we have P of x equals x cubed minus x squared minus 6x. And for B, P of x equals 2x cubed minus x squared minus 18x plus 9. So remember, when you're factoring, you first look for what they have in common. Then there might be a special pattern. You have to factor it completely. So maybe you take something out in common, but then you have to recognize if there's a special pattern or if there's a trinomial, then we might need to guess and check with FOIL. Okay, I'm going to have you guys factor this right now, and you can work with your row or table on this, and then I'll call on different rows or tables to share with me what they got factor-wise, okay? So take 1 minute to do that. Well, more than a minute. Let's do 2 minutes. All right, let's see how we did. Okay, so for part A, you know, what did your row do first? Yep, and what was that? What'd you take out? X, yep, okay, and then what'd you get inside? But inside here, X.
X squared minus x and minus.
Awesome. Okay, and then once you do that, can you break this down again? Okay, and then Jaden, what did you guys get here? Great. Okay, so this is the first answer. This is your factored form. Okay, and then the second thing they ask you is to use that to find the zeros. So to find the zeros, you're going to set this equal to 0 and solve. Okay, and you can only do that when it's equal to 0. This one you don't even need to solve for. You can just write what x is and then put your solutions in any order you'd like. Okay, and you are going to have 3 solutions there. Okay, so when you solve, you're adding the 3, you're subtracting the 2, okay, and that's how you're getting those solutions. Okay, and the number of solutions does match your degree. All right, and then Cedric, what did your table do first for B? Yep, so great. Okay, so if there are 4 terms, we're going to factor by grouping. Okay, and then Mira, what did you guys take out for the common terms here? X squared, and then sorry, what'd you say you got inside? Good. Okay, and then what'd you take out here? Good. All right, so then when you're writing your factor, you have x squared minus 9 as the first from what you had on the outside, and then 2x minus 1. Okay, and then Claire, did you guys go any further than this? Yes. Yes, so x squared minus 9 is x plus 3 and x minus 3. That's the difference of your two squares. Okay, so we are going to factor that down one more time. That's a special pattern. Okay, so this is your factored form. So whenever you're doing factored form, you do need to just factor that completely. Okay, so don't leave any special patterns unfactored. Okay, and then when we set these equal to 0 and solve, we are going to get our final 0. So we should have -3, +3, and 1/2 as our zeros. Okay, questions for me on this part? All right, and then for example 3, you are going to graph the polynomial. Okay, and then you're going to determine how many local maxima and minima it has. And then we are going to round to 2 decimal places where appropriate. Okay, so you are going to have the option for this to do decimals or your graphing calculator. Okay, and then if you, what do you think it's going to be here? Decimals or your graphing calculator? You guys do think you're graphing calc? Or we only say graphing calc because it takes me too long to open the Chromebook.
Well,
I get it. I completely understand that. I also,
don't like the.
yeah, and I get that. Like, now that we're so good at all this mental math, sometimes you guys are not even want to take out your calculator because it's quicker to do it out. Yeah. I agree. Okay. All right, so I really do think, I think it'll be easier on Desmos because when you are trying to find your maxima or minima, all you have to do on Desmos is click a point. Isn't that just so nice? Yeah. Okay, and then remember you do get to use Desmos on the PSAT. Okay, so right away we can tell how many maxima, how many minima does it have? 15. Okay, and then it's local. So when it says local, it means in the area, because technically these are going to infinity. Okay, so there wouldn't be a maximum, but there is a local maxima. Okay, so how many local maxima do we have? 1. And then what? We just click on this bad boy. 0, 4. I'll click on these for you so you can round. Okay, I'll keep it up there, but all we're gonna, oh, sorry, I didn't write down the thing for you. I'm sorry about that. Okay, so we're doing y equals x to the 4th minus 5x squared plus 4. And you can either graph in your graphing calculator or Desmos. Okay, this one you can see in your standard window. So honestly, that part is going to be simple to do on either one. Okay, but when you are finding the points, I do like Desmos because you can just click. Okay, so you have one local maxima at, and then we could all see that that is 0, 4. So I'm just going to write this out for so you can see the format. And then you would say there's 2 local minima at, and we're just going to write those as points. Okay, so I'll keep that up for you so that you can round appropriately. or if you want to do it on your graphing calculator, you just have to go to second, hit that trace button, find the minima. Okay, so then from there, you are going to have negative 1.58 and then negative 2.25. Okay, and then I'm just going to put it here. These are symmetric, 1.58, negative 2.25. All right, and then the exit flip, we're actually going to do that now, and then I'll put the homework up on the board once some of you have finished this activity. So you're going to do this with your table or with your row, and once you get to step 3, where you have this piece of cardboard that's 8 inches by 10 inches, it says that you're making a box. You're really just making the bottom of the box. It's a tray, okay? So you're going to be making a tray out of paper, and I'm going to be giving you guys paper, but before you cut anything, you're going to have to fold it. All right. Now, I want to warn you that this isn't something that is supposed to be easy, that you're all going to know how to do right away. You're going to have to work with your row and your group and do some problem solving, okay, in order to get this correct. And then I'm going to walk around and help you. Okay, this is for a classwork grade today. And then once you guys have finished that and got it checked, I'm going to let you move on to starting your homework, okay?